Hello guys, my name is Lance Antonio and we're going to be talking about moment of inertia for this week's topic. So what we're going to be covering in this week's presentation is table of contents, the general concepts, basic formulas, moment of inertia, example of moment of inertia. So the first one is our general concept. So you all may be thinking about what is moment of inertia. So moment of inertia is a mathematical expression used in the study of strength of beams and columns. It measures the effects of cross-sectional shapes of beams on the beam's resistance to bending, stress, and deflection. So in other words, a better example of that would be alternate definition. The portion of shape which are located further from the axis have greater effect than the parts which are closer. A good example of this would be a beam section with a large moment of inertia will have a smaller stress and deflection under a given load with a lesser I value, and the I stands for an inertia. So in this example right here in figure 6.6 and figure 6.7a, as we can see in the first one, it's not bending as much due to the way it's positioned, but in figure 6.7a, while it's turned horizontally, you could tell that it has less of a strength and starts deflecting. So now we're moving on to the basic formulas. So in our basic formula, since this concept doesn't have any accurate physical analogy or description, the dimensional unit for this moment of inertia I is in inches to the fourth power, and it's just like that. So in figure 6.6, the area in their perimeter were b times h inches square, and their parameter is 2b plus 2h inches. And since we're dealing with moment of inertia, where the formula for this right here in figure 6.6 would be I for inertia equals bh cubed over 12 inches squared. So an I value has the unit of length to the fourth power because the distance from the reference axis is squared. For this reason, the moment of inertia is sometimes called the second motion of an area. More importantly, it means that the elements or area that are relatively far away from the axis will contribute substantially more to the I value than these closer by, just like what I said in the last one. Sorry. So the moment of inertia I is always compute relatively to a reference point or axis, just like as we can see in the second part of that diagram. The most useful and often used reference point is the centroid axis. So that's just basically what we basically learned in last week's video. So this is what the basic formulas are. So for the shape, that's like a cubed, and that's what I just went over. Then the triangle, circle, inner circle, and semicircle. So number 3, moment of inertia of an area. So a concept to help think of motion of inertia is a figure skater. Imagine two shapes shown in the figure 6.8 to be cut out of 1/2 inch steel plate and placed and spun about in x-axis. The two shapes have an equal area, but the one in figure 6.8a has a much higher moment of inertia I with respect to the axis of spin. It would be much harder to start spinning once it's moving. It would be much harder to stop. Oof. So number 4, an example problem. So this is the example problem number 1, 6.6. Determine the value of I about the x-axis. So if you guys really want to, you guys can pause the video, try to figure it out. If not, I'll give it a second. Okay, we can continue. So the solution to this problem is right here. Step number 1, we figure out our solids. Then step 2, we figure out our voids, correct? So our solid is 6 and 6. Then for the voids, it's 4 and 2. So for step number 3, we know that it's a square, so we're dealing with the I solid equals bh cubed over 12. And then for the opening, it's 2 times that, because you're basically doing the two of them. Then step 5, you're doing that. Then step 6 is the opening, so 2 times 2 inches over 4 cubed over 12 equals 2 that. 21.3 inches cubed, 4. Then step 7, you combine all of it and you subtract. Then you basically get 86.7 inch 4. And that's basically it for this one. I just want to give you guys an overview of what you guys are going to learn in this week's lesson. If you guys have any questions, you could just message me or watch the other presenters' videos to try to get a better understanding of what this week's presentation is about. So, see you guys next time.